Welcome to today's webinar, RDS for Oracle and SQL Server, simplifying your database management and reducing total cost of ownership. Our presenter today is Prahlad Rao. Prahlad is a senior technologist with diverse and extensive background across technology and strategy consulting in areas of cloud, data center infrastructure, enterprise systems, and virtualization. He has over 19 years of experience in enterprise architecture, delivery, consulting, pre-sales, and IT operations for customers of all sizes across industry segments. Today with us, we also have Lynn Ferrante, Phil Ethantar, Dallas Willett, Michael Veras, and Chaya Poundy. They will serve as our webinar moderators and will engage with you and answer your questions throughout the presentation while Prahlad presents. Prahlad, welcome. The floor is now yours.
Thank you very much. Good afternoon, everyone. And thank you for joining for this webinar again. My name is Prahlad Rao. I'm an AWS Solutions Architect. The webinar title is RDS for Oracle and SQL Server on AWS. So let's take a quick look at the agenda topics today. So we'll first start with a quick overview of Amazon RDS and go through some of the benefits of managed relational database services. And then we'll go deeper into some of the specific features and capabilities of Amazon RDS for Oracle and SQL Server in terms of capabilities around features, backup, HA, and licensing options. And then we'll also take a look at some of the concepts and architecture around migrating databases using AWS Database Migration Service. And then finally, we'll end up with a demo of migrating a SQL Server database to an RDS SQL Server instance. So we have a full agenda, and let's get started. So before we actually dive into some of the RDS concepts, I think it's important to kind of set expectations on the concept of AWS regions and availability zones. So AWS infrastructure is global. Our customers can deploy workloads across any of the regions there. And then we are also continually expanding to add more regions and availability zones. So for folks who are unfamiliar with some of the concepts around regions and availability zones, it's slightly different than how other providers do. So a region is essentially a geographic boundary where customers can provision resources. For example, your database resources, EC2 instance, and whatnot. And then within each of the regions, we have what we call as multiple isolated data centers called availability zones. So you always have more than one availability zone in the region. So that means you can actually run your application database workloads across multiple availability zones, which means you get intrinsic high availability capability when running on the AWS platform. Within the AWS Database Service portfolio, we offer a number of options for running your databases. Among those are Amazon RDS, Amazon ElastiCache, Amazon DynamoDB, and Amazon Redshift. While each of these services offers different capabilities and features, what we are going to take a look at today is some of the specific features and capabilities around RDS. So RDS is the classical relational database services that allow you to run your database, whether it's Oracle SQL Server or any number of open source database technologies like MySQL, Postgres on Amazon platform. So from an Amazon RDS offerings perspective, as I mentioned, we support various database engines ranging from commercial engines, Microsoft SQL Server, Oracle, we support Microsoft SQL Server, 2008, 10, 12, so we'll take a look at some of those underlying engine details, Oracle 11 and 12 as well. And then various open source engine, as you can see, MySQL, Postgres, Maria, and Amazon own develop engine, which is called Amazon Aurora, that is based around MySQL engine. So why do customers want to use Amazon RDS? So for customers who are trying to get started onto AWS platform, you can easily run your database engines configured on an EC2 instance, which is a virtual machine, virtual server on our AWS platform. But why do customers want to look at something like an RDS service? So of course, we have some assumptions that with this webinar, we are going to take some of the deeper look into some of aspects of RDS, but I'll take a very quick overview of what is RDS, why use RDS. So RDS is a managed database service. So this service allows you more time to focus on your application and you can focus on your schema design, query consolidation, optimization, while taking all the heavy lifting of managing and provisioning the underlying infrastructure, the database, leaving that to AWS. So this gives you a quick launch into getting started with provisioning a database engine in under 10 minutes, and then providing you instant provisioning capabilities, scale up and scale down capabilities, all that is fully managed by the Amazon RDS service. So if you host your database on premises, obviously you as a customer would be responsible for the entire stack, ranging from hardware setup, the operating system installation, database engine installation, backups, HA, and application optimization. Whereas if you host that database on our Amazon EC2, which is based on virtual machines, you still get some benefits. That means Amazon will be responsible for managing the underlying infrastructure in terms of hardware, rack and stack, and some of the maintenance activities. While you as a customer would still be responsible for operating system and above, which means you need to still install database engine, maintain the patching, updates, and application optimization. However, when you use Amazon RDS service, you get all the benefits of a complete managed database experience, while you can focus on your application in terms of optimization, schema design, and whatnot, so that provides the best value for your business. So let's take some of the quick look at each of the high-level features and capabilities within the RDS platform. So that means I'll start with some of the HA concepts and then go on to security, backups, and whatnot. So let's start with HA. So when you actually launch an Amazon RDS instance, you can actually go for either the single AZ model or the multi-AZ model. So with multi-AZ, you get a very high availability database architecture where you can get a primary database engine that will be available for your read and write, whereas a secondary standby database engine will be provisioned for you on a separate availability zone. So with multiple availability zone configuration, you're going to choose the availability zone in which you want your primary database instance to be in. The RDS service will then choose to have a standby instance and storage in another AZ in the region that you're operating in. The instance will be of the same type as your master and size as your primary. The RDS service will then take the responsibility for ensuring that your primary is healthy and that standby is in a state that you can easily recover to. So that means some of the common failure scenarios are completely mitigated. Loss of availability zone, connectivity to an availability zone, and also any compute or storage failure on behalf of the instance. That will ensure that the primary database instance will be automatically failed over to the standby instance, and then the standby instance will be erected as a primary, and while you can continue to serve your applications. That means there's no endpoint, there's no need to use a different endpoint, so you can continue to use the same application without having to change your application configuration. Security. Within Amazon, we call what we call as a virtual private cloud, which is your own isolated section within the Amazon environment. So this gives you complete isolation as to how you run your applications and workloads within a VPC, which means you can bring your own configuration around network, subnets, IP address, and also security firewall rules that you can easily segment within the VPC so that you can run your database within your own VPC. So this allows you to run your database in a securely managed container that you as a customer can provision and then have full control over it. From managing a connectivity perspective, you can easily connect your VPC to your on-premise data center, either through an AWS Direct Connect, which allows you to have a private fiber connectivity to your on-premise data center from AWS VPC, or you can also take advantage of VPN connection. That means you can use the public internet to be able to connect to your VPC or resources within VPC and then have the data encrypted at rest or in motion. You can also take advantage some of the concepts around VPC peering that allow you to actually connect different VPCs together and then set various routing rules and other configurations that allow you to easily manage your database instances securely within a virtual private cloud. Scaling compute and storage on RDS. We offer a wide variety of instance types suitable for most workloads, ranging from a single CPU to up to 40 CPUs and 250 GB of RAM. So there are various instance types and categories that we support, categorized into various instance families, whether you're looking for more compute-intensive instance types are more tuned towards memory capabilities, or if you require a very high network throughput for your database instances, you can pick and choose the instance type you want. And then from a storage perspective, we also support various storage types, from magnetic, which is the spinning disks, onto more SSD-based provisioned and general purpose IOPS-based EBS volumes that you can easily attach to Amazon RDS instance that allow you to run your RDS in critical production workloads that require higher I/O. The computation and memory capacity of instance is determined by its instance class. You can easily change the CPU and memory available to an instance by changing the instance class. That means you can easily move from a lower instance type to a higher instance type and backwards as well. However, you need to modify the instance, but that's a very simpler process where you can easily switch to a different instance type and then move on to a higher instance category. We support, as I mentioned, various instance types, instance families that allow you to actually start with the smaller instance types, and then when you need higher capacity, higher performance, you can easily migrate to a higher instance type as well. Data encryption at rest. I think this is again one of the important aspects of our RDS services. We support RDS encryption in motion for all 6 engines. That means whatever engine that we support on RDS, all 6 engines are supported for encryption in motion using SSL. In addition, we also support encryption at rest using our KMS. So that means when you actually host your database engine on database on our RDS instance, the data that is residing on the RDS will be encrypted at rest. You can also take advantage of our key management service, which is our KMS, which provides you high scalability, reliability for managing your key and also be able to actively rotate your keys. You get to focus on your applications and integrating with the service, leaving all the heavy lifting of managing the encryption, the key management onto AWS. For RDS, you get an extra layer of protection, right? So encryption, we use industry standard AES 256-bit encryption to protect the data. We also support CloudTrail integration. That means any API calls, any activity that is actually done to the RDS can be easily tracked, audited, and then maintained through our CloudTrail integration. So all this provides immense benefits to our customers. It limits risk of compromised data key, better performance for encrypting large data, and also be able to manage large number of master keys. One other thing that when you're encrypting your primary database, any backups or replicas that you take will also be encrypted at rest. That means you can be safely assured that any of the backup that you are using will also be encrypted when you encrypt your master database. From an access authentication perspective, we use what we call as IAM, which is our AWS Identity and Access Management that allow you to implement IAM policy that restrict who can do what against your RDS infrastructure. It's important to note here that while you can have your own database authentication username and password within the database engines that allow you to actually log into the database at the logical SQL level. But from an IAM will allow you to actually govern your database. That means who has access to the database, whether they can launch the database on certain instance type, who can terminate the instance, who can terminate an RDS instance, who can modify an RDS instance. So these are some of the constructs that we provide as part of the IAM Identity and Access Management. Compliance. One of the reasons that customers are concerned with security is that they have to have a certain compliance requirement that they have to meet, whether it's in terms of FedRAMP, HIPAA, or any kind of compliance. AWS has a lot of different customers in the startup, enterprise, and public sector space running wide range of applications and workloads across many different industries. Some of these applications and workloads require that they meet certain regulatory compliance. So to support the audit and compliance requirements, AWS has worked to achieve certification that you can run your workloads on RDS and be able to achieve full compliant application. So for RDS, we currently support 9 different compliance authentication, including SOC 1 and various other certifications that are clearly documented in our AWS portal. In addition to that, we also highly recommend that when you pick and choose a region, the data will stay in that specific region unless you as a customer decides to move the data out of a specific region. Monitoring. When it comes to monitoring, there are a lot of different measurements and metrics you can examine. With no access to the host operating system. So the benefit and also some of the concepts around RDS, I'll talk about that in a minute. Yes, you will not have access to the underlying host operating system, but you should still be able to get all the relevant metrics from your operating system. For example, CPU, memory utilization, file system, disk I/O metrics. All this needs to be captured so that you can effectively monitor your RDS instance. By default, RDS provides you access to over 50 new CPU memory file system metrics so that you can get up-to-date real notification metrics that allow you to integrate with your CloudWatch to get active notification for all your RDS instances running on the AWS platform. In addition to that, we also give the option to turn on enhanced monitoring. While we provide basic monitoring, we also provide enhanced monitoring that you can turn on. So that will give you an additional 37 metrics that you can actually combine with the metrics that you get from your basic monitoring to better help understand what is going on in your database instance, and then so that you can tune and appropriately scale the instance as required. Durability. Again, this is another important aspect of running databases on RDS. We provide 2 different options for our customers to take advantage of durability. So that means one is automated backup. That is part of the RDS service. We provide daily backup, incremental log offloading every 5 minutes to support all your backup from an automated perspective. You can also vary that backup retention up to a 35-day limit. That means you can restore a backup can go all the way up to the 35-day period to go ahead and restore a database backup. We also provide point-in-time recovery. At any point in time, you can actually go back and restore up to the last 5 minutes of the database usage. All these backups are automatically stored in S3. And here again, this is an automated capability within the RDS where you don't need to actually take a snapshot, copy that to S3, and then maintain the backup and recovery. It's all done by the RDS service. In addition to that, we also provide flexibility to our customers. If they want to take manual snapshots, you can always do that at any point in time. So these are full copies of your RDS database instance at a point in time, and and those are again backed up by the durable Amazon S3 object storage. So you can actually use the snapshots to actually create a new RDS instance. So let's say you want to you're running your primary database and then you don't want to use the primary database for maybe some kind of read reporting or maybe some kind of activity that you want to test before you probably upgrade the features or maybe update a schema. What you can easily do is you can restore the point-in-time database onto a new database instance and then have that available to your users so that they can test, and they can also test the functionality, or they can use that for read-only workloads. So that will allow you to actually easily provide flexibility not only from a DR or a recoverability perspective, but also gives the user the ability to actually offload some of those duty onto a separate database instance. And as I mentioned that if you are encrypting your primary database, the snapshots, the backups will also remain encrypted. So that means you are assured that any of the backup copies are also fully encrypted. We have numerous customers that are using RDS today. This is a partial list of customers. As you can see, we have a variety of customers ranging from startups to enterprise that are taking advantage of the capabilities on RDS. So now that we have set some of the features and capabilities for RDS in general, and that applies to mostly to all engines, let's take a look at some of the specific capabilities around Oracle and SQL Server. So I think one of the important aspects is when customers look at RDS, obviously they'll ask the question that how do I choose the right solution for your needs? how do I make a decision whether I want to use RDS for whether I want to use an RDS or running Oracle on traditional Amazon EC2 instance. While you can do both on our platform, we always recommend to our customers that you give RDS a try first because it eliminates a lot of undifferentiated heavy lifting for your DBS to have to contend with. That means you can focus on your application optimization, schema design, rather than managing the underlying infrastructure, the operating system patching, the database upgrades, and whatnot. So we always recommend that you go with RDS first unless you have a real reason not to go with RDS. This will give you focus on high-level tuning tasks and schema optimization. And then obviously some of the cloud-born companies, when you have a lack of in-house expertise managing database, that means you don't have dedicated teams for managing your database infrastructure, you don't have teams for managing your overall infrastructure operations where you're mostly focused on your application and your workload for your business applications, then again, this is a very good fit where you really don't have to focus on managing all the underlying infrastructure. However, as I mentioned, when you go with RDS service, you'll not have root access to the underlying operating system that the RDS runs. So if you really require full control of your database instances, then you probably need to look at Amazon running your database on Amazon EC2 instance. But again, there's additional overhead in managing all the backups, the patching, operating system, and also database tuning as well. So RDS for Oracle provides you with a quick launch, speed of provisioning, secure, fully managed RDS experience. That means you can quickly launch an Oracle database engine in a matter of minutes on our RDS platform that includes any of the multi-AZ high availability capabilities. That means, let's say you're using your own Oracle Data Guard and other capabilities to be able to have an active standby database on your on-premise. You know the pain of setting up primary database, secondary database, applying the logs, making sure that the licenses are accounted for, and so on and so forth. All that is completely taken out when you're going with RDS for Oracle because we give you a complete managed experience. So it will give you a single-click HA auto-scaling that allow you to manage your RDS from a SQL perspective and not having to manage the database from an underlying operating system infrastructure perspective. We also have flexible licensing models. That means if you already have a volume license agreement with Oracle, you can easily bring those licenses on AWS platform. So we support both bring your own license as well as license included model. Within the license included, we support both standard edition SC1 and SC2. So that means you have the capability to be able to be flexible in your licensing model. But however, we always recommend that look at your capabilities, what you want to do today, and then if you can easily take advantage of license included, you don't have to deal with all the complex licensing options with commercial database engines. We also provide ease of data migration movement. I'll talk about some of the capabilities around Database Migration Service that allow you to easily migrate, replicate data from on-premise database engines onto our AWS RDS services. We support the latest version of Oracle 11 and 12c as well. And then some additional new capabilities we also support. Oracle Label Security option, Oracle Enterprise Manager Cloud Control that allow you to have a single view of manageability for your existing on-premise database engines that you are managing through Enterprise Manager, and also be able to use the same for RDS as well. We also provide support transparent data encryption. That means if you're already taking advantage of TDE for Oracle or SQL Server, we support TDE, partitioning, and some of the advanced compression with your own license supported model. So there are multiple ways to actually provision an RDS instance for Oracle. While we support the traditional RDS management console for one-off provisioning, but obviously when we have customers using all the automation capabilities to be able to deploy their workloads on AWS, we always recommend to either take advantage of our command line tools where you can easily script provisioning of database, or your favorite SDKs, whether you are Python shop, Java shop, you can easily use our AWS SDKs to be able to provision quickly your RDS resources on the AWS cloud. We also provide a lot of quick start templates, CloudFormation, that allow you to completely manage deployment of RDS as infrastructure as a code. That means you can easily construct how exactly the RDS instance will look like and then code that using CloudFormation JSON templates and then be able to simply provision that using all your CloudFormation templates. So this gives you the ability for repeatability, consistency, auditability, where you can manage your all set of resources as code. With HA, I think, as I mentioned, that sometimes it can be a pain to be able to set up HA on Oracle, whether you're using Oracle Data Guard or Golden Gate. I think it can get pretty complicated if you have tens of hundreds of Oracle database instance. You need to need to manage HA capability, data guard, applying the replication logs, whatnot, setting up the redo log and everything, right? So all that has to be managed by you if you're running your own database on an EC2 instance or even on premises. So with RDS, with a single click, so this is all it takes. If you're using console, all it takes is a one click to be able to deploy that on a multi-AZ deployment. So that means when you say multi-AZ equals yes, we will automatically provision a primary database and a standby database instance across multiple availability zones, and that's all you need to do. So it's pretty easy. You can take advantage with a few clicks or a single API call to launch a highly available multi-AZ RDS database instance. For customers, while we provide, as I mentioned, multi-AZ capability within a region that provides intrinsic HA capability, a lot of our customers also ask, well, that's great, but I also want to actually replicate the data across regions. For example, I already have my RDS engine in US East region. I want to replicate data to maybe US West region because maybe I want to provide a copy of my database to a different set of applications as users in a different region. So in which case we support cross-region DR in AWS. So that means you can easily snapshot an RDS engine and then be able to copy the snapshot to a different RDS region. So this gives you capability where you can easily copy your snapshots at a point in time, make that snapshot copy available in a different region, use that snapshot copy to restore onto a different database instance on the second region or the new region, and then provide that capability to your end users. Pretty powerful. There's no charge for the copy operation itself, but however, you need to probably pay for the data transfer out when you're transferring data across regions. But still, it gives you a lot of flexibility and powerful capability to be able to not only use the cross-region capability for DR, but also be able to use it for across various application workloads. In addition to that, we also support, if you not only for just migrating or for DR, if you have an active replication that you want to maintain across different regions. We support what I call AWS Database Migration Service. I'll talk about some of the concepts around Database Migration Service in a bit. I also have a demo that I'll show that to you in terms of how can you migrate. But you can easily use our AWS Database Migration to be able to maintain an active logical replication between database instances across regions. And also, if you are comfortable with using something like an Oracle Golden Gate, you can also take advantage of that. So from a license portability perspective, we support pretty much all the Oracle software license. As I mentioned, we support both bring your own license as well as license included model. All Oracle software licenses are fully portable to AWS on EC2 and RDS. So whether you have your enterprise license agreement or any kind of Oracle partner network, you can take advantage of some of the licensing capability to bring those licensing onto the AWS platform. We support various capabilities. Obviously, I'm not going to talk about each of this, but as you can see, we support various options in terms of the standard edition license, enterprise edition license, and then some of the multipliers around what it means from a core multiplier to the virtual cores. For more details, you can always refer to the Oracle Cloud Licensing Policy. You can also refer to the Virtual Cloud Core Table that we have made available to our customers that gives you some of the details around all this cores to the socket capability there. Uh, Now let's move on to SQL Server. So the SQL Server gives you the same experience as on-premise. That means it's dedicated instance. We provide the same level of capabilities in terms of speed of provisioning, secure, fully managed RDS experience, similar to Oracle that I just mentioned. And again, it provides you with single that allow you to easily provision SQL Server instances and then be able to scale as well. Like Oracle, we support both flexible licensing model, bring your own license and license included model, depending on what kind of volume licensing agreement you have with your Microsoft partner. We support various versions of SQL Server, Express Web Standard and Enterprise Editions. We also support the newly available 2014 as well. In addition to that, like Oracle, we also support various capabilities around easy data migration movement using our Database Migration Service. And broad set of engine features capabilities are supported. So let's take a look at some of the underlying capabilities on feature perspective. So running RDS on SQL Server versus EC2, I think we talked about for Oracle, it has the same kind of guidelines. Always look at running SQL Server on RDS first, unless you have a real lead or maybe there's something blocking that you have to go with EC2. But as you can see, we support broad ranges of versions. 2008, 12, and 14 are supported in RDS. And all these editions are supported across both RDS as well as on EC2. We support multi-AZ deployment on RDS for SQL Server. For running SQL Server on EC2, we support various options, whether you can use your own self-managed replication tools, always on, and mirror and other capabilities. Encryption support, we support encryption capabilities using KMS and transparent data encryption support for both of these flavors, RDS or EC2. Windows and SQL Server authentication. This is big for customers who are big Windows shops who are using Microsoft Active Directory to be able to have single sign-on capabilities for accessing your RDS instance or SQL Server instance. You have this. That means you can easily take advantage of a single sign-on capability using Active Directory to be able to provide authentication mechanism for RDS for SQL as well. The various capabilities I talked about in terms of providing managed automated backups and automated software patching as well. So I talked about Windows authentication support. So essentially this gives you a lot of flexibility and powerful capability where if you already have your Microsoft Active Directory on premises, you can easily integrate that using a one-way trust onto the cloud. So the way you do is you set up an Active Directory controller on the AWS cloud and then have that domain joined to your on-premise directory. So once you do that, you can easily integrate your RDS, which is running SQL Server, and enable for Windows authentication. So what it does is it'll go back to your on-premise, get the authentication for you, and then so that you get a single sign-on capability. A lot of our customers have asked for capability that allows them to easily migrate their on-premise SQL Server instances or data to AWS Cloud. While I mentioned you can always take advantage of some of the SQL replication tools or AWS Database Migration Services to be able to migrate database easily from on-premise to RDS, we also support a capability for that allow you to have native backup restore. That means if you have your existing SQL Server database running on premises, all you have to do is take a full backup, right? Take a backup of your SQL Server database, store the database backup as a back file on our Amazon S3. Once you do that, you can easily import that backup file on our RDS services and then be able to launch that RDS for SQL Server. Pretty easy, right? Pretty easy and pretty powerful. So this allows customers who does not want to use maybe say replication tools, migration capability, but rather just have a backup restore capability where they can easily back up to the AWS cloud and then store that on S3. This provides powerful capabilities. So the way you do it is you first create an Amazon S3 bucket on the AWS, and then so that will be used as your landing point for your backup file. Once you do that, you create an IAM role, which is an identity access management role, to grant your relational database service access to your S3 bucket, because RDS will actually go talk to the S3 bucket, get the data, and then restore that on the RDS instance. And then you attach the role for your RDS instance using option group. I can probably talk about that, walk through the demo. And then you can use your standard or your favorite SQL Server Management Studio called stored procedure that exposes that backup file. So all you have to use is the stored procedure on RDS and then be able to easily restore that onto RDS for SQL, and there you go. You have your complete up-to-date backup that's fully restored on RDS. So it's pretty easy, pretty powerful capability. From a HA capability, as I mentioned, we support multi-AZ capability. So that allow you to run production workloads in a multi-AZ mode. So where the primary is your active database that will be used for read and write, and then the secondary will be a standby that will be launched in a secondary availability zone. And for RDS for SQL Server, we leverage SQL Server mirroring. So that means all the database transactions will be applied to the standby database. So where you don't need to really apply the logs and then bring up the standby database, that's all completely automated, transparent for your users. From a tooling perspective, we support all common tools. So if you are already using SQL Server Management Studio to manage your database on premises or even on EC2 instance, you can continue to use the same tools to manage your RDS as well. So you don't need to actually switch to a different tool set where you can continue to use your existing tool set to manage RDS. And then in addition to that, as I mentioned, you can also use the migration capability with Database Migration Service, or you can use the SQL capability to be able to easily move the data onto RDS. We also support various data sources from some of these sources for SSAS and SSIS as well. So this is an architecture. I hope that it's not too small for you to see the picture. Maybe it's a little bit muted there, but nevertheless, the architecture that you're seeing here is a fully integrated, fully Microsoft AD integrated with your on-premise. That means you already have your on-premise existing Active Directory controller, and then you're setting an AD controller on the AWS platform, and then be able to tying that to the RDS service. That means you can use SQL Server, AD authentication to be able to domain join, and then be able to connect using your single sign-on. From an AWS VPC perspective, you can see the various subnets that will be configured. Obviously, your domain controller will reside on a private subnet that will be connected to your on-premise infrastructure, either through direct connect or through a private VPN connection. And then the RDS instances will live its own DB subnet group. So you can easily connect to the database instance either from your existing on-premise or through a remote desktop gateway service as well. So all this provides you with powerful, flexible capability that allow you to easily integrate your existing toolset, existing sign-on capabilities to be able to manage RDS for SQL Server. Let's take a look at some of the cost perspective. Obviously, when you're running your database on RDS, you need to optimize for spend. That means you need to be able to choose the right region, right instance type, storage type, what you want, depending on your workloads, whether you need a high performance data storage like provisioned IOPS or magnetic disk for devitest workloads, whether you want to go for single AZ model versus multi-AZ for prod versus devitest, and what kind of workload pattern. And also, I think license plays a very important role from a cost perspective. So let's take some of the options around that. With RDS, like with Amazon EC2 instances, we have pricing models where you can easily launch your database on an on-demand model. That means you pay by the hour, there's no long-term commitment, you grade for workloads that you don't need to run 24/7, right? So for example, devtest or even some of the workloads that does not need to be running all the time 24/7, you can easily go for on-demand that gives you easily scale out, scale in capabilities. For workloads that needs to be run 24/7, for production workloads that will be running all the time or a set period of time, maybe 1 year, 3 years, you can easily go for reserved instances. So reserved instances allow you to save up to 60% over on-demand cost. That means we provide various options within the reserved instance, from no upfront, partial upfront, all upfront, where you can pay a little bit upfront when you launch your instances and then be able to amortize the cost over the lifetime of the instance, whether it's 1 year or 3 year model. So let's compare from an actual costing perspective, pricing perspective, how it'll pan out, right? How does your monthly bill look like? So let's say, for example, you launch an extra large Oracle dev test instance that will be used 24/7. Let's say you'll be running all the time, although it's a dev test instance, and then you're running an M4 extra large instance using your own license. Bring your own license model with Oracle, and then you're picking Oregon region, which is US West 2, and then in the multi-AZ on-demand model with 100 GB of SSD storage. So this is how your bill look like. So you're paying for 730 hours and then whatever the cost and the cost of the storage. So you'll be paying approximately about $534 per month for having a highly available database that includes both the primary database instance as well as a standby database instance that will be running 24/7, although it will be using an on-demand model. Now let's take a look at RI. When you're using reserved instances in place of on-demand for production workloads, obviously if you're running 24/7, we don't recommend that you go with on-demand, but rather go with reserved instance that allow you to save cost. So here you can take a look at an exact cost comparison where you're running the exact same configuration, M4 extra large with your own license, and then a multi-AZ where you're paying no upfront RI. So keep in mind we provide options for a small upfront, full upfront, no upfront. With full upfront, you get even more significant discount. But let's say you don't want to pay anything upfront, but still, as you can see, you'll end up paying about $344 per month. And then if you compare that to $534, this is still significant, right? So always, when you're looking for running your database instance, look at some of the capabilities around how you want to run, whether you want to run the instance 24/7, whether you're running production workloads, multi-AZ, single AZ, because that will dictate how much cost you'll end up paying. But always when you're running production workloads, when you have persistent workloads, look at reserved instance that will allow you to save significant cost. All right, so database migration service. So this allows you to move data to the same or different database engines. So obviously there are various challenges in migrating, replicating data from on-premise to AWS. But however, we have made it easy through the AWS Database Migration Service that allow you to keep your apps up and running during the time of the migration, and then you can easily migrate the database or replicate the data to the AWS cloud. We support all those engines, as you can see. And then when you're ready, actually you can easily flip the switch and then move towards the AWS cloud. So this is how it works. So you set up what we call as a database migration service replication instance on the AWS cloud, and then you have your existing database on premises, and then you establish the connectivity either through a direct connect or a VPN connection. And then once you set up a replication instance that I'll show you in a bit on the demo, you will be able to start the replication where the replication instance will connect to your source database running on premises, and also it will connect to your target database that will be run on the AWS. So you need to have the target RDS database instance running ahead of time, because you will be essentially replicating the schema of the data from your source database to the target database, all the while that your application continue to access your primary database on your custom or on your on-premises. So once you do that, you can either choose for a continuous replication, and then you can easily switch at any point in time when you want to migrate or switch over your application to the AWS cloud, or you can do a one-time migration. If you want to do a one-time migration, you simply you take a migrate option, and then all the data will be migrated from your source database to the target database. You can pick and choose the database tables, specific schemas that you want. So it's not like all or nothing. So if you have a database with 10 different database tables, 10 different instances, whatnot, you can actually go very granular. You can pick and choose the schema you want, the table you want, and then be able to move that granularly. It gives you powerful capabilities where you want to migrate either partially or fully. So as I mentioned, you can load table by table. You can also fan out from one source database to multiple target database engines. You can also use change data capture so that the updates are constantly applied to the target database when you're doing a CDC replication. That means you want all the data that are the transactions that are happening to be able to capture and then be applied to the target database. You can do that as well. And I just clearly mentioned that the DMS, which is the Database Migration Service, not only supports homogeneous, that means Oracle to Oracle, SQL to SQL, we also support heterogeneous migrations. That means you can easily migrate from a commercial database engine like Oracle or SQL Server to more open source database like MySQL, Aurora, and Postgres. So this gives you very powerful capabilities for our customers looking to optimize, save cost, and also be able to move the database onto the AWS cloud. Now it's demo time. So let's take a look at some of the capabilities around database migration services and also the ability to launch RDS. So if you see my screen here, I have logged into the AWS console, and then you can go to the RDS console here. So when you go to the RDS console, you'll see the resources that are already in play there. So click on DB instances, you'll see all the database instances that are running. So I have Aurora database, I have some Postgres, I also have a SQL Server database running. So in the demo today, we'll be looking at how you can migrate a SQL Server database running on an EC2 instance to be able to replicate or migrate the data to a SQL Server on RDS. The same thing can be applied to a database running on your on-premise. So nothing changes from a procedure perspective as long as you have connectivity between your on-premise and AWS. So all the configuration for DMS, the configuration will stay the same. So let's take a look at some of those. So before I start with the database migration service, I want to quickly show you how we can easily launch a database with our RDS dashboard. So click on Launch Database Instance, and then you can actually choose any of the database engines you want. So let's select Microsoft SQL Server here. So here you have the choice to select whether you want Express, Web, Standard Edition, or Enterprise Edition. Let's go with Standard Edition. Here you can pick and choose, as I mentioned, whether you're running a production or devtest. So what will define here is whether you want to go with a multi-AZ deployment with a provisioned IOPS storage, or if you're running a devtest sandbox, you can easily start with a single AZ model. So click on devtest and next step. So here you're provided with various options. So we'll go with license included model. And then the database engine version. So you can choose from a variety of database engine that we support. So we pick maybe, let's say 12. And here you have the option to select any of the instance class. So keep in mind, you can always move to a different instance type easily as well. So we pick the M4 large. And then you also have the option to pick a time zone. So if you're running your database on the Eastern time zone, you might want to go with the Eastern Standard Time. So multi-AZ deployment, if you just click yes, this is all you need to do to set up a HA, primary active standby instance for either Oracle or SQL Server or any of the other database engines as well. You can also choose the type of storage you want, general purpose SSD versus provision, that will be based on your application requirements, whether you want high performance storage or simply the magnetic disk for your dev test workloads. And then select the allocated storage you want. So we go ahead and select an instance identifier, maybe let's say my RDS DB, and then select a username, select a password here, confirm password. So it already exists, so let's give a different instance. So all it has to be unique. So here you can actually pick and choose the VPC that you're launching your database. So if you already have an existing VPC, you can choose the existing VPC, or you can totally choose a new VPC where you launch your database instance. And then some of the configuration or subnet groups, the security group that allow you to control inbound and outbound traffic to your database instance. And here you can specify what type of authentication you want. Since I don't have an Active Directory setup, you'll probably choose the none. If you already have an Active Directory, that will pop up here that allow you to select that for your SQL Server authentication. And then you can pick the database port option. Here you can specify the database retention period, how many days the backup has to be maintained. You can go all the way up to 35, or if you don't want any backups for a dev test, for example, you can choose 0. And then if you want enhanced monitoring, you can also pick and choose that. So once you do that, you click on launch database instance, the database instance will be launched for you. I'll not be doing that because I'll be showing you the database migration service. But once your database is launched, you have your database running here, you can see here, and then you can actually go and see the details here. So the details will be, this is the endpoint you want. So if you're using your SSMS Management Studio, you would require the endpoint to be able to access. So let's go and take a look at the SSMS that I have. So I'm running that on go here. We don't need this. So this is a SSMS Object Explorer. So as you can see, I have actually configured the RDS instance that I launched earlier that you can actually manage using SSMS. So if we refresh, you'll see the database that's configured on the database engine. So we have a MyDB database instance running on that. And then if you look at the tables, there's no tables currently. So there's no data on that. What we are going to do here is I have another database instance. I have a database running on my EC2 instance here, which is basically here, as you can see. So this is using the AdventureWorks database, and then we have a few tables here that we are going to replicate using the Database Migration Service, and then migrate that data to the MyDB, which is actually on the RDS database engine. So what we are going to do is, so there's no tables here. We are going to use the human resources data from the EC2 instance, which is a SQL Server 2014 running on an EC2 instance with the data here. So let's go to the dashboard for DMS. And then what we are going to do here is the endpoints are, we need to specify when you start a database migration service, the first thing you need to do is launch a replication instance. The replication instance is responsible for connecting to the source database and to the target database, and then copying the data, replicating the data using the replication instance. So we need to make sure that this replication instance can talk to your source database and the target database. So we already have that set up. And then we also need to configure the endpoints. So the endpoints here is, one is our source database endpoint, which is on the EC2 instance that I just showed. And these are some of the configurations. This is the endpoint. And then this is the engine. These are some of the details. The username is specified and whatnot. And you can also test the connection. Make sure that the DMS instance or the replication instance can actually talk to the source database. So let's make sure that it can talk to the source database. It should take a minute. So the replication instance will go and connect to the source database and then make sure that you can connect to the database, be able to access that. Once it does that, it'll give a successful status, and then we can go ahead and do the same thing with the target database as well. So it's important to run the step because of the fact that the replication instance needs to be able to connect to both the source as well as the target database. You can see here the status is successful. That means the DMS can talk to the source database. Similarly, I have the target database, which is our RDS. And if you see the connection here, I have specified the endpoint, which is the RDS endpoint, the port, and then the password here. So I can go ahead and specify the password and then say modify. And then this is the database. This is where the data needs to be replicated to, which is the target database. So now we have both the connection established. Let's go ahead and create the task, which is the actual replication task. So we'll create the task. We'll call it as SQL replication. And then we'll use the replication instance. We'll pick the source endpoint, which is our prod endpoint, which is a SQL Server on EC2 instance. And then we'll go ahead and use the my RDS target, which is the RDS SQL Server instance. So you can choose the option whether you want to migrate all the existing data or migrate existing data and replicate ongoing changes, which is mainly used for ongoing replication, or replicate data changes only if you already have replicated a set of data to your target database and you just want to replicate the difference. So there are various options here that you can configure, pretty simple there and self-explanatory. And then here, you can actually pick and choose the exact database table that you want to migrate. As you can see here, it automatically pops up, shows up all the schemas that are available for us to migrate. So let's pick up human resources data that we are going to migrate and then create task. So here, what it's going to do is DMS now goes ahead and creates the task, connects to your source database, connects to the target database, and then replicates the data. So it will take a minute or two to be able to replicate the data. I know we are probably running short on time. We should be able to complete that in the next couple of minutes. So bear with me here. While it's getting to initialize and set up all the connections and then be able to replicate the data, once the data is actually loaded, you can also take a look at some of the table statistics. While it's not available now because the data replication hasn't started, but once the replication is completed, it will show all the exact details as what schema it migrated, how many tables, what was the DDLs that it got migrated, how many rows and whatnot. This will give you a lot of capability insight into how your data was replicated from source to target. In addition to that, you can also encrypt the data. That means, so now the data replication has actually started. You can see the status that it's starting the replication. You can also replicate the data, or you can also encrypt the data in transit. That means if you're really concerned about security when you're migrating data from source to target, you can easily encrypt that using on the DMS as well. So it's go ahead. It's continuing to start the job. And then it'll show the status as full load, complete 100%. After that, let's go ahead. Now it's completed. So for some reason it failed. So this is one of the things about the demo guard. So let's take a look at some of the data here. So it was able to transfer a lot of data here to the target database and then see what we have on the status of the actual database instance. Let's take a look at that and then see whether it has actually migrated the data or so there you go. You can see that although some of the tables probably failed, I need to look at that, but as you can see that the data has in fact been replicated or migrated to the target database here. You can see the human resource department and some of the data. So let's do a quick query. So this is your source database, and then let's execute the query to make sure that it has all the data, and then let's copy this query. I'm going to change this. And then what I'm going to do here is use the tables here. and then create a new query on the target database. And here I'm going to paste so here, instead of using my adventure works, I'm going to do a MyDB because that's where our database, target database is. So once you do that, you're now querying the target database and look at how all the data that was in the source database has been successfully migrated to the target database. So that concludes our demo and the presentation. I'm sorry for some of the time or running over the time. And let's take a quick look at some of the